Hello and welcome to another little bit of maths with Mr. Thompson, and today we're going to be looking at a little bit of Cartesian geometry. We're going to look at some properties that come up when you look at the line between two given points, namely the middle of the point of the line, the gradient of the line, and the distance between the 2 points. Okay, so we're going to take a very simple example and work through all three of these one at a time with the same example. So let's take a line segment from the points 1, 1 and 9, 7, and we want to find the halfway point of that line. So that's going to be the point about there somewhere. Now, basically, how to do these, there are formula for these, and we'll look at them at the end of this clip, but really, you just think about it. To get from that point to that point, we go 8 along and 6 up. Therefore, to get to the midpoint, we're going to go 4 along and 3 up, just halfway there. So if we're starting at 1, 1 and we add 4, we're going to get to the point 5. From that coordinate there. And if we start at a y coordinate of 1 and we add 3, we're going to get to the point 4, 5, 4. And that's just halfway along the line. What we want to look at when we come to look at the formula is that the 5 is equal to the average of the two x coordinates, 9 plus 1 over 2, and the 4 is what you get when you average the two y coordinates, 7 plus 1 over 2. So when we look at the formula, this is what we're going to be writing down in mathematical terms. Okay. What about the gradient of that line? Well, we know the gradient is just the rise over run. And the rise in this one is 7 take away 1, which is 6. And the run is 9 take away 1, which is 8. So the gradient is equal to 6 over 8, which is 3/4. Now, we observe again that value of 3 is simply, before simplification, excuse me, the value of 6 is simply 7 minus 1, the difference in the y coordinates. And the 8 is 9 minus 1, it's the difference in the x coordinates. So that y difference over x difference is where we're going to get the gradient from. Finally, let's look at the distance between the points. Well, we can essentially construct a right angle triangle here with this distance d, and then we're just dealing with simple Pythagoras. So it's going to be this distance here squared plus that one squared equals d squared. Well, once again, that distance there, the x difference, is 9 minus 1, so that's 8 squared. 9 minus 1 squared plus 7 minus 1, which is 6 squared, and that's going to equal d squared. So that's going to be 8 squared plus 6 squared equals d squared, and we should recognise that as a Pythagorean triple. Indeed, 64 plus 36 is 100, so d equals 10. Okay. But observe, it's the difference between the x coordinates squared, difference in the y coordinates squared, which gives us the hypotenuse squared. So brace yourself for the mess that's coming next. We'll look at all three of those in formula form. Okay, there it is there. We write down on our plan that the difference between the y coordinates is y2 minus y1. And the difference between the x coordinates is x2 minus x1. So therefore, do the gradient first, I suppose. The gradient is just the y difference divided by the x difference. Okay, that's what we had a couple of screens ago. The distance formula is just the difference between the x's squared plus the difference between the y squared to give us the distance there squared. And finally, the midpoint, if you remember, is actually just the average of the two. We add up the x values and get their average, and you add up the y values and get their average. And that gives you the midpoint of the line. And really, I would urge you to cast these formula from your mind. And whenever you're dealing with this type of question, just refer back to the simple diagrams. If you're asked to find the midpoint, draw a sketch, work out what's halfway there and halfway up, and you'll get the midpoint. When you're finding the gradient, draw a sketch, find out what the rise is, find out what the run is, and you'll get the gradient. And if you're asked to find the distance, draw a sketch, get a right angle triangle, use Pythagoras, and find the distance that way. That's how to look at it. You'll be given the formulas in your exam paper, use them as a guideline, but to solve these ones, you draw a picture and you get them down on paper.